interwebs, welcome to Let's Fix Computers. I've got a MacBook Pro here. This is a 2 Thunderbolt port device and it does not turn on. And if we plug in a charger with this energy meter on it, you can see we start on 5 volts, then it steps up to 20 volts, but it's not drawing any meaningful amount of power at all. There is a very low quiescent there, so just idle background power. But it's not charging, it's not trying to turn on, it's not fluctuating in any meaningful way. These super low numbers, these are completely meaningless. So what we would be looking for here is that it starts drawing some amps or some watts that would indicate that it is switching on or charging or doing something. And we might even see a pulse where it turns on and then turns off, which would indicate some kind of power cycling. But it's doing absolutely nothing. It's stone dead. So the fact that it's negotiating 20 volts is a start. That means that the Thunderbolt chip inside is powering up and saying, yes, I will accept 20 volts from you, Type-C charger. So that's something. But then the fact that we've got nothing else, that means there's probably a power fault deeper in the laptop. So we'll just close the lid of that. And I've already taken the screws off of the back here. And what we're going to do now is have a look. So the customer has removed their SSD from this laptop because it has sensitive information on it. So that's why there's a hole where the SSD is supposed to go. Likewise, we can also see that this has had a replacement battery in it at some point. So that may or may not be related to the fault, but it's just worth noting things that are not standard in the laptop. This doesn't look like an awesome battery either. It doesn't look like it has a meaningful brand on it, but that doesn't mean that it's bad. So just some thoughts. Anyway, so what we want to do is we want to see if there's some kind of basic power in the system and what the basic power rails are doing. So let's come down on the board here and we'll take some measurements. So I'll connect power into the side of the laptop again. I'm not expecting to see anything here, but we'll just have a quick look. And what I'm going to do is I'm just going to put my red probe on the fuse here. This is the PP Bus G3 hot fuse, so the main power rail in the laptop. And have we got, just go over to voltage, do we have any power here? No, there's no power here at all. So that's why the laptop isn't doing anything. And if we unplug it, there will still be no power. There should be residual power here from the battery. However, clearly the battery isn't powering anything either. So let's check. Is there anything coming from the battery? There's some residual there. I think the battery is off or flat though. So let's disconnect the battery and we'll take some resistance measurements. So now we're up into resistance mode. And let's have a quick look over here. So PP Bus G3 hot. Wah, wah, wah. That is basically a dead short. So we've got 0.6 ohms there, most of which is probably in my probes. Interestingly though, if I probe the other side of the fuse, there's 4 ohms. So we seem to have some resistance through the fuse. I don't know why that is. I'm not sure if that's normal or not. I'm fairly certain it isn't. However, we have a short on the main power rail. That's the important thing. So what we're going to do now, we're going to take the logic board out and we'll take a closer look at that. That capacitor there is for the audio amplifier on the other side of the board, if my memory serves me. And I've seen this guy go before, and he looks kind of discolored. I'm going to get the microscope on that. I'm just wondering if this one's actually going to be that easy. Now, I've seen capacitors with darkened legs on them plenty of times before, but man, that guy really looks like he's in a state. He also looks like he's welded himself to the board. I don't know, guys. What do you think? Are we just going to, like, without doing anything else, just take that guy off the board and try our luck? I think I will. Because that guy does not look happy. Apparently this one is notorious for failing as well. So firstly, just for posterity, let's just observe that this guy is shorted. And as you can see, we've got 0 ohms on either side of it. So that is on PP bus G3 hot, which we already know, but I'm going to put some Kapton tape over the connectors for the speakers, just to make sure we don't damage those with the hot air. Shout out for the folks who are suggesting that I get some hot tweezers. That is a good shout. Would make this bit a bit easier, but it's not mission critical. It can be done without them. However, what I will do, because I'm expecting this guy to give me trouble, I'm just going to touch up the solder on each side of it first with some leaded solder. And that will make my life a little bit easier. And here's the hot air. I'm at 400 degrees C, about 70% airflow. I don't want to linger too long because otherwise I'll damage this plastic connector. I want to avoid that if I can. Come on, don't fight me. Don't make me do work. Am I too close? No, we're okay. Kapton tape is doing its work. Whoops. No, I forgot to put my mat underneath. Well, there's the first burn hole in the nice new mouse mat. Sad face. Alright, so how about this capacitor? Our survey says winner, winner. That's a shorted capacitor. So, in that case, if we pull the board back in and we measure on the fuse again, and we're now seeing high resistance on PP bus G3 hot. Easy peasy. Well, I would be disappointed that it wasn't complicated enough for us to do voltage injection and stuff like that. However, this is an important lesson. Firstly, remember how I always say how I have no luck doing a visual inspection of the board? Well, I did a visual inspection and I immediately saw a capacitor that looked really dodgy. And it was also a capacitor that is known for failure. And also, this was a point where we had a short circuit on the motherboard and we didn't just immediately go, voltage injection! We said, no, wait, let's actually have a look at it first. So, let's replace that capacitor. I'll open up the schematics for this guy, just so we can see what it is. So, here is the board view for the 008 00840 logic board. And the capacitor we are looking at is this guy here, C6445. So I'm in Flex Board View here, and that means what I can do, I can just right click on this, search, and it will automatically jump to it in the schematic for me. And as you can see, this is a bypass cap for U6440, and that is 4 times mono speaker amplifiers. So it's a quad channel amplifier, or no, actually I lie. Nope, it's a mono speaker amplifier, but there are 4 of them. So yeah, that's kind of interesting. These will be scattered about the board. There'll probably be a couple where we're working and a couple on the other side of the board for the other 2 speakers. So yeah, that is a 22 microfarad 25 volt capacitor. So let's dig into the capacitors and get some of those out. Now, I don't have any 22 mic capacitors. I've been caught out by these a couple of times, and I still haven't ordered any. I'm going to double stack some 10 microfarad capacitors there, because I don't have any 22 microfarad capacitors. I will also order some 22 microfarad capacitors today, because this is the 3rd time I've needed them. This is a common capacitor size, and also this is a classic known to fail capacitor on this particular board. Okay, so I've got some 10 microfarad capacitors here. So these are 106, that's 10 and 6 zeros, which makes them 10 million picofarads, which works out at 10 microfarads. So I'm going to stack 2 of these here. With capacitors, assuming that they are the same value, if you put them in parallel, then you combine the capacitance of them. So 2 10 microfarad capacitors in parallel will give me approximately 20 microfarads of capacitance. Now, obviously, we're aiming for 22, but 20 is close enough. These are just bypassing. It's close enough that it's going to do its job. If we put them in series, so we had 2 10 microfarad capacitors in series, we would still have 10 microfarads of capacitance, but we would combine the voltage tolerance. So these are 25 volt capacitors. In series, we would have 50 volts of tolerance there. However, obviously, we're working on a 12.8-ish volt rail here. So the 25 volts that these can tolerate is more than what we need. So what I'll do, I'm just going to clean up these pads a little bit. Put some extra flux on there. I've got genuine Amtex flux now. I found a UK supplier thanks to a friend. So we've got the real deal now. And so far, it does work a bit better than the fake stuff. Right, and let's just flatten that pad there. Oh, come on. Whoops. This is a ground plane here. I remember working on this bit last time. Sucks the heat out of your iron. Now all I need is some not terrible braid. Alright, that's good enough. That pad is flat enough. Okay, right. I've cleaned the board with alcohol, so we've got some nice flat pads there. Okay, right. Let's put in some fresh flux, and we'll get these guys both on the pad. And thankfully, everything sticks to the flux syringe, because why the hell not? There we go. All right, here we go. Still practicing working under a microscope. The monocular microscope that I'm using doesn't give me any depth perception, so it's a little tricky to work with. However, it does give great magnification, which is very nice. So I'm just going to squeeze these guys together and just get them on one pad. Oh, one of them is stuck down. Alright, that doesn't look terribly convincing. I'm going to do those from the other side, and then we'll come around and touch that up. So we'll turn 180 degrees. There we go. A little bit blobby, but that's good. Now we'll touch up this side again. There we go, look at that. Okay. Alcohol to clean up. And as you can see, we've got those two capacitors now in parallel on the existing pads. Doesn't exactly look factory, but that'll work just fine. Right, we're all assembled, so let's plug in some power. Right, we're kind of stuck fluctuating between 7 watts and nil. However, because the battery is stone dead, I think it's just upset. So I'm just going to give it 5 or 10 minutes just to trickle some power into the battery and try and wake the battery up. Because I think that's what it's doing. It's trying to wake the battery up. And I reckon if we give it some time, we should see that click on to actual full charge wattage. So I'm going to give this 5 or 10 minutes and we'll see what it does. Right, an update. It hasn't come good yet. However, I think we are still waking up the battery. What I can do here, I've left the cover off the battery, and over here, if I put my black probe on ground and my red probe on the battery MOSFET here, just probe there, and what we're seeing there is battery voltage, and you can see we're at 9.2 volts and very slowly climbing. That's the charger cutting out, and then it's cut back in again. And can you see how the battery voltage is very slowly climbing? This is an 11.4 volt nominal battery. It's a 3-cell battery. So if we do the maths there, at 9 volts, we were down to 3 volts per cell, which is critical. And it's most likely that the cells were actually much lower than that when I initially plugged it in. So it looks like here that the battery had deep discharged into that short circuit and was probably critically low. Now the battery should cut out at low level. So the BMS, the battery management system, because this is a third-party battery, not sure what it's actually aiming for here. However, thankfully that same BMS has not locked up. A lot of batteries, if they go too low, the BMS will just lock and that's it, the battery's done. However, in this instance, it is allowing itself to very slowly be just trickle woken up. So it's probably going to wait until we get to, I don't know, 9.9, 10 volts, something like that, which would be 3.3 volts per cell. And once it hits that amount, it will probably say to itself, okay, the battery is now up to 0. We will now charge. And at that point, we're likely to see the charger kick into actual charging mode, and it'll start giving it the beans. So once again, I'll come back to you in a bit, hopefully when that's happened, and we should see that the voltage on the battery is up at a sensible level. We should see it up into 10 or 11 volts and actually charging properly. Okay, this thing has had time now, and unfortunately it has not magically come good. We're still fluctuating on power. So if we have a look at the voltages we're getting, if I look at the battery MOSFET, we're now getting sort of 11.8, and then when it switches off it drops to 9.4. So you can see that we've actually put some charge into it, and if I actually probe the battery contacts themselves, the actual cells, we're getting 11.1, and when it clicks on, that creeps up to 11.15. So over time, those little slow pulses of power do seem to have woken up the battery. However, it still doesn't want to charge it. Now, what concerns me is the fact that when it clicks off, the MOSFET level there, the output drops all the way down to, what was that going down to, 9 point something? Yeah, 9.4. Now, I'm not sure what that means, is the short answer. I have a suspicion that this battery is toast, and although we've managed to nudge the voltage up, it's not it could be that the battery has completely fallen out of balance or something like that. That's my guess here, but I'm not sure. So what I need is a replacement battery, but I don't have one. So the question is, am I going to order a replacement battery and hope for the best, or what else could I do? Well, I do actually have a bit of equipment that's specifically designed to deal with this scenario, and that is this guy here. So remember when I did a review of this a couple of years ago? It's my NLBA professional laptop battery analyzer. And this is a little widget that will connect into a laptop battery and talk to the BMS, and it will allow me to analyze the battery to determine its health, charge and discharge it, and it can also unlock or reprogram certain batteries. But I don't have the wiring harness to connect up a battery like this one to it. So I'm going to see if I can jury rig something together. So in order to talk to the battery on this laptop, we need some of the data lines going to it. Now that ribbon cable looks kind of scary, but it's actually a lot simpler. Here's the connector for it. That's the main battery tab. So like if we look at the main battery tab, we've got four positive connections here, and then there's 6 ground connections around the outside. And what's 1 and 2? Oh yeah, sorry, I'm an idiot. Yeah, there's 6 positives and then there's 6 negatives. Now the actual data connector here, it's got a lot of pins on it, but most of them are actually unused. The only ones that are actually relevant is pins 2 and 3. That's serial clock, serial data. And then pin 7 is sysdetect L. And what this pin does is it pulls pin 7 down to ground through this resistor over here. And what that does is it tells the battery that the battery is connected to something, and that will switch on the battery. So if this pin is not pulled low, then the battery will not turn on. And that protects it against like the battery connector being shorted out while it's not connected to something or anything like that. Apple batteries nearly always have a detect line on them, but most PC batteries don't have this pin. So as you can see, there's actually only 3 pins that we need to be concerned about here, and then the main plus and negative. So if I can get some jumper wires onto these pins from the battery, I can connect them up to my battery analyzer, and then we can actually look at this battery properly and see if it can be recovered or not. Okay, behold my madness as I attempt to solder some jumper wires onto the pins of this battery. Wouldn't recommend this, if I'm honest. This is dumb and kind of stupid, but I'm kind of curious as to just like, yeah, this is a, can I do this? Can this be done? Was that the pin I needed? I'm going to double check. Yep, I'm on the right pin. That should not be connected. Good. Next one up. Yes. Good. Okay, right. That looks like a horrible mess in there. Let's see if it's actually adhered. Gaze ye upon my abomination, and despair at its majesty. So we've got positive and negative hooked up, and we've got our clock and data pins hooked up. Now, I mentioned that there was a system present pin. However, I've also determined that we don't actually need that. We should need it. However, this battery seems to be always on. It doesn't seem to be respecting the system present pin. Because if I measure the voltage now, there's voltage at those terminals. There shouldn't be without the system present pin there, or system detect. However, it is. But that's because this is a crappy low quality battery. So, right, the output light has come on. Because again, the battery is always hot, and it shouldn't be. Can we get this all into view? That's good enough, I think. Now I need to hook up power and USB to this guy. And read all once. Okay, so the good news is it worked. Alright, so this is kind of interesting. Let's just have a look at the data that we've just managed to read out of the battery here. So firstly, the battery is actually in good health. This battery is not very old. It's practically brand new. It's at 100% health. The cells are actually balanced just fine. And it has actually managed to put some charge into it. It's reading as 48% charged. However, and that must have been the trickle that I left running into it overnight. However, the BMS is flagged as locked. However, because this battery doesn't seem to respect its own BMS, it doesn't seem to respect the system detect, it doesn't seem to respect the lock status, it was still actually taking on charge because it doesn't seem to be able to switch off its own cells. So you can force power into this. I'm kind of curious as to if it will actually allow me to charge it. However, because that is flagged as locked, I'm guessing this is why the laptop is rejecting it, because the laptop is reading the battery and it's seeing that the battery is marked as locked. Okay, well, that's interesting. So I wasn't expecting the battery to be locked because it was outputting power. But I think that's down to the actual design of this battery. This battery is incredibly cheaply designed, and it seems to have a controller on it that is just enough to satisfy and provide the information that the laptop wants to hear, but doesn't actually do anything to protect the battery in the slightest. A proper BMS should have protected the battery from being discharged like this, and that probably would have prevented it from actually locking up in the first place, or maybe anyway. At the very least, what we have determined now, we have proven that the battery has failed. So now, if I go and get a new battery for this, I can be reasonably certain that the laptop is going to run again because we've replaced the busted battery. So this was an entirely ridiculous way to come to this conclusion, but it was an interesting proof of concept. I think what I'm going to do is I'm going to make up a wiring harness for MacBook Pro batteries like this one. So the next time I encounter a battery in this situation, I've got a less janky wiring harness that I can connect up to it. Because if this had been, where's a regular battery? If this had been just a regular laptop battery like this old HP battery with these connectors, what you would do is you'd take these spade connectors that are on this current wiring harness and you just stab those into the correct pins on the battery. And there's a database. For the software for this battery analyzer that will tell you the pin out for most batteries. So you just stab the spade connectors in and you read the battery directly. The difficulty here was that I just don't have a wiring harness for this, which is why we've just done this horrible amalgamation. But if I actually sat down and spent time making up a wiring harness, the next time I'm in this position, I'll have something that I can very quickly connect and determine if the battery is shot or not. Failing that, by virtue of the fact of what the voltages are doing when we connect and disconnect it, we can also make some reasonable assumptions that this battery looked pretty sickly. All we've managed to do here is just prove that. And by proving it, I know that I can buy a battery and not be wasting my money. So, past that, I'm going to go get a battery. Okay, final piece of the puzzle now. We're going to change out this battery, and based on everything we've discovered, as soon as we do so, we should find that all of the problems with this laptop will actually go away. I'm 99% certain that the laptop is fully functional now. It just doesn't have a working battery in it. And unfortunately it needs one, which is very annoying on Apple laptops, but there it is. Right, I'm going to take out the screws holding this down. Then this guy is glued in, but because it's not the original battery, hopefully it shouldn't put up too much of a fight. I'm actually going to do a quick pry test without even putting in any alcohol and just see how well stuck down that is. The answer is yes. It is very well stuck down. Okay. Let's try one more time from there. That might be a good entry point. Right. Let's get some alcohol down there to melt the glue. And I'll alcohol down the sides of all the cells just so that's slowly working its way in. These plastic scrapers are great for getting glued in batteries out. Just got to gently get it underneath the cell and then it just starts, you can just push it through the adhesive. Oh, there we go. That's not putting up any fight at all now. Easy. That's one done. I'm not sure how to tackle that middle one yet. We'll come to that in a moment. Right, what was that bump that I'm encountering? Okay. So when you dig down, you can see there's actually a ridge there, which is why it felt harder than it actually was. So you've just got to actually get over that ridge. Oh, that was a bit of a bend. There we go. It was a little bit rough there, but it's okay. Good. Right, that's that battery out. So it bears mention that this battery would probably be a good candidate for unlocking. It is possible to unlock a lot of batteries that are in a locked state. And the NLBA laptop battery analyzer that I've demonstrated in this video is actually one of the tools that can do it. However, I'm always very dubious about it. I have to admit, I have not had much practice at unlocking batteries. And so for that reason, I'm not very confident that if I unlock it, that battery will continue to be okay. I'm just preferring to replace the battery in short. And the replacement unit that I'm using is this NinjaBat brand battery. Now, this particular NinjaBat has really bad reviews on Amazon. There's only 2 reviews and they're both 1-star, which doesn't inspire confidence. However, I've fitted a lot of NinjaBats to a lot of laptops and I've not had a single bad one yet. So, although this is not, I don't think this is one of their finest batteries, but I have a lot of confidence in the brand, and also because it's from Amazon, if there's any problems, you just send it back and you get a refund. So I can provide a full warranty on this and I can say to the customer, if you have any problems with your replacement battery, bring it in and we will deal with it free of charge. So warranty is what you need here. Right. Hi, it's me from the future. Unfortunately, the battery turned out to be a lemon. However, as I just said in the video, this is why we provide warranties. The customer did call up a few days after picking up the laptop and said, yeah, the battery's not holding charge. So the laptop is coming back in and we will be replacing that battery with a different brand one, completely free of charge. And that one will be going back to Amazon. So I do still stand by NinjaBats. This has been the first time I've had a bad one from them. And the rough looking reviews on Amazon, I think, were the warning for that one. Most of their other batteries do get good reviews. At any rate, they're not available in all countries, so if you do have any other recommendations for batteries that you have had good experiences with, and what country that they sell in, then do leave a comment down below and share the knowledge. Let's get back to the video. I'll be fitting the NinjaBat, but again, that one was a lemon. Get a different brand. Just out of interest, is this battery respecting the system present pin, I wonder? Yes, it is. That inspires a bit more confidence over the battery that's come out, that this one is actually respecting the system present pin, which is good because obviously these batteries have exposed connectors on them. So you don't want the battery to switch on if it's not actually connected. So yeah, that's actually quite good. I'm going to line up the controller, followed by the center cell, and then let the other cells kind of drop into place. I think I'm a bit too high. Right, those guys seem fairly comfortable. I'll just see if I can get them straight as well, just so it looks a bit nicer. Ah, that's fine. It's not perfectly straight in there, but that's just aesthetic. Nice confident 11.6 volts from the battery and PP bus G3 hot. Looks like it's in standby. Don't like that wavering. Oh, if this doesn't work, I'm going to be furious. Right, something weird is going on here because, again, we've got battery voltage coming out of the battery at the MOSFET. Then if I check one side of the PP bus G3 hot fuse, we've got 11.6 from the battery. And then on the other side, we've got that weird wavering 3.3 something, and it's jittering. You can see the bar graph at the bottom of the multimeter is jittering. Also, remember how there was like 4 ohms of resistance across that? I'm just going to double check that that's actually a fuse and I've not completely misinterpreted what that is and what it does. Because I think I'm being punked here. Right, yes, it is a fuse. So I guess just that fuse must be blown because it shouldn't have resistance across it. I've never seen it sort of be partially blown like that before. That's extremely odd. We still had a faulty battery, we know that. Because also, like, the battery is not charged off of this section. But look, there's like 80 ohms. This fuse must be like partially blown, which is just really odd. I've not seen that happen before. I don't know if that's a normal thing, but yeah, that's what it looks like. So we'll need to get a new fuse in there. Fine, okay. I'm going to get a hold of a new fuse. I might have one in stock. Failing that, I'm going to grab one from a donor board. So the fuse is a 12 amp 32 volt fuse, which is a very common fuse found on a lot of modern Mac boards. So I'm going to steal this one from a 2014-ish. And then we'll put it on the new board. Alright, and now to avoid having to take the board out the laptop again, I'm going to try dual wielding soldering irons to do a poor man's hot tweezers on this fuse. So I'm just wetting the joins on it. There we go. And let's try our luck. Oh, it feels stuck down. There we go. Nice flat pads. In one of the pads. And in comes our replacement fuse. Having trouble getting my soldering iron tip in here. I might need to switch off of the knife edge because it won't physically fit in. If I put a solder blob on there, that will help me out. No. There we go. That was the most brutal soldering job on a fuse ever. When you're being lazy, you have to ask yourself, would it have been faster just to pop the board out so you weren't having to work awkwardly? There we go. Other side is easy. Good enough. Right, let's do some checks again. So now we should find that we don't have that weird phantom resistance across the fuse. I was not aware that a fuse could partially blow because that's literally antithetical. That is the opposite of what they should do. A fuse should not go high resistance. It should just blow. So yeah, very, very odd. So now across that fuse we have... damn it. 0 ohms, which is what it should be. There we go. So now, when we plug in the battery, we should now see that we have full power on PP-Bus G3 Hot. So, again, just as a reminder, this weird fuse was nothing to do with the old battery. The old battery was still kill. It probably would have powered up the laptop if we'd fixed the fuse. However, it would not have charged properly because it was in a locked condition. And that would have turned into another problem. And now we should find we now have 11.6 volts on PP-Bus G3 Hot. And that is enough to switch on and charge. So, one more time for the road. Bam. There we go, straight away, straight up to 20 volts. And we have 20 watts and rising. So this will slowly increase as it starts pulling more and more to charge the battery. We also have fan spin, and we just had a little I'm charging beep out of it. So there we go. This thing is now alive. The battery should be about 50% charged, so I'll just disconnect that just so I can open it up. And we should also find it switches on as well. Oh yeah, of course. Yeah, it's not going to start up because there's... Okay, we've got flash and question mark folder because there's no SSD in it. Because of course there isn't. However, we win. Okay. Man, this was a laptop that had a really, really easy fault. But it just kept going, one more thing. You also got to deal with this. However, lots of little gotchas with this laptop. But that is now fully functional. And we're done. There we go. Right. Back hub will go back on, and this guy is ready to go out. So, actual original issue, just a bad capacitor next to the audio amplifiers, which is a fault we've seen before, and so I hear a very common fault with these laptops. However, this was accompanied by the fact that the replacement battery in there had fully drained out because its BMS was not wired up to respect system present and stuff like that. Because the connectors on it are always hot, the laptop was able to just pull the battery down to stone dead, which killed the battery. That battery is potentially recoverable if you can be bothered for a cheap battery. However, we've slapped in a new Ninja Bat, which is a higher quality battery. And we've also replaced that dodgy fuse, which was just weirdly giving high resistance, and I don't know why. Not quite sure what the deal with that fuse is, but replacing it has resolved that issue. So, problem solved, one fixed laptop. Thank you very much for watching, everyone, and I'll see you next time. Bye.